In this video, we're going to learn about graphing from intercept form. In particular, we are going to be graphing quadratic equations that are in intercept form. Before we look at some examples of intercept form equations, let's just review a few examples of equations in vertex form. That's a little different from what we're doing today. Here's an equation that is in vertex form because we can look at it and we see that the vertex is at the point 3, 5. Here's another equation that is in vertex form, and by looking at the clues in the equation, we can see that the vertex is at the point -7, -4. Intercept form equations look a little differently, of course. Here's an equation in intercept form, y equals x minus 3 times x plus 2. And here's another equation written in intercept form. Now, these examples of vertex form equations are quadratic equations. When we expand this out, the highest power is x squared. And it turns out these equations are also quadratic equations. Looking at the graph of this vertex form equation here, we notice that the vertex is at the point 4, -1, and there's some clues in the equation that tell us where that vertex is. Now in intercept form, the clues are a little bit different. The clues in the intercept form equations are going to help us locate the x-intercepts. So when we're looking at intercept form equations, we're going to be first looking at the x-intercepts. Now notice both of these graphs are parabolas, and that's because they're both quadratic equations. To see why equations written like this are quadratic equations, let's go ahead and expand it out. So when we multiply two binomials, we end up doing 4 multiplication problems. You might work out those 4 multiplication problems with the help of a box. I'll just go ahead and use this FOIL method. So x times x is x squared. X times 3 is 3x. -1 times x. And -1 times 3. So when we multiply these two binomials, we see that we do indeed get a quadratic equation because the highest power is x squared. So let's look a little closer at these x-intercepts and the intercept formed equations. So in the equation y equals x minus 1 times x plus 3, we see that the x-intercepts are at +1 and -3. Now notice these x-intercepts are closely related to these two binomials that made the equation. X equals 1, we see that's the opposite sort of this, and x equals -3 is like the opposite of this one. Let's see if that pattern holds true here also. For this equation, the x-intercepts are at -4 and -1. And once again, we notice there's a close relationship between the x-intercepts and the two binomials. We had an x-intercept of -4 and an x-intercept of -1. We'll take a look at one more here. This parabola has x-intercepts at -1 and +5. And once again, we see that close relationship between the x-intercepts and the two binomials. We had x-intercepts of -1 and +5. So here's a generic quadratic equation written in intercept form. Now the a, that will control the steepness. If a is a fraction less than 1, we'll have a less steep parabola. If a is greater than 1, then we'll have a steeper parabola. Now, with binomials of x minus p and x minus q, that would give us x-intercepts of p comma 0 and q comma 0. Now remember, the x-intercepts always have y values equal to 0 because we're along the x-axis and we're not up anything. Let's take a quick moment to make sure we understand why it works that way. Well, like we just mentioned, the y value at the x-intercepts is always 0 because we're down there along the x-axis, so we're not up anything. Let's go ahead and replace that y with 0 and dig a little deeper with this equation. Well, here we have two things being multiplied and that equals 0. That means one of these two binomials must equal 0 in order to get a product equal to 0. Well, if the first binomial is equal to 0, then x plus 7 must equal 0, because we're saying this whole piece must be 0. So if we subtract 7 on both sides, we get x equals negative 7 as a solution to this equation. We can also do that for x minus 1. If x minus 1 equals 0, we add 1 to both sides, and we get x equals positive 1. So if we substitute positive 1 in for x, well, that turns this binomial into 0, making this true. If we plug in negative 7, then that makes this binomial 0, making this equation true. This idea is called the zero product property. All right, let's use these ideas to help us graph these equations written in intercept form. All right, so for this equation, we're going to have x-intercepts at 5 and 3. To kind of organize our thinking here, we can say x minus 5 equals 0, which means that x would have to equal 5 to make that happen. So I'm going to go ahead and mark an x-intercept at 5. And if the second binomial is 0, then x must equal positive 3. So here we have our two x-intercepts marked. Now, since parabolas are perfect reflections of each other, when we look at the left half and the right half, well, we know that the vertex then must be halfway between 3 and 5. Well, it's easy to see here that the number 4 is halfway between 3 and 5. By the way, if it's ever not obvious, we can always add the two x-intercepts and divide by 2. And that would tell us the average of these two x values. Okay, so we know that the vertex will have an x value of 4. But we don't know the y value yet. Well, we have an equation, and we can substitute 4 in for x and solve for y. So I substituted the 4, and that's where we know the vertex is, into this equation for both x's. Working that out, we get y equals negative 1. So the vertex must be at 4, negative 1. Let's get that point on our graph. We can make a pretty good sketch with just these 3 points. Well, let's do a little bit better and get 2 more points on there. Let's see, notice that when we went over 1, we went up 1. So our first move was over 1, up 1. Thinking back to what the parent graph for this is, y equals x squared. That one had a first move of over 1, up 1, just like this. And the second move was over 2, up 4. So we're thinking that point will be here. Let's go ahead and verify that. All right, so let's use an x value of 6. So let's find out what the y value is when x is 6. So I'll take that 6 and substitute it into this equation for both x's. So when x is 6, y is 3, just like we expected. And then we can reflect over to the other side of the parabola and put that other point there. So we first located the two x-intercepts. Then we found the x value of the vertex, which is halfway between the two x-intercepts. We substituted that x value into the equation to find where the vertex is located. And then we just found one more point to make our parabola. In the second equation here, we can use x plus 3 to help us find one of the x-intercepts. So one of the x-intercepts is at -3. And we use x plus 1 to find the other x-intercept. So the other one is at -1. Now, once again, it's easy to see that the vertex of this parabola is going to be at -2 because it's halfway between -1 and -3. But we don't know the y value of that vertex yet. So let's substitute -2, the x value of our vertex, into this equation. So we have a vertex of -2, -2. All right, we notice that this parabola is going to be a little steeper. And that makes sense because we have this a value of 2. So if we were graphing just y equals 2x squared, the first move would be over 1 up 2, and the second move would be over 2 up 8. So we're thinking that second point will be here. Let's double check. So here, the x value we want to find now, or we want to use 0 to find the y value when x equals 0. So I took that 0 and substituted it into this equation for both x's. Let's work out the y. So another point on the parabola is the point 0, 6, just like we expected. And we can do a reflection of that point over here. We have a pretty steep parabola here. One difference with this equation is we notice that a is negative. So we understand there's a -1 right there. Let's start with the x-intercepts. We can use that x plus 3 to figure out that one of the x-intercepts is at -3. And the other one is at +1. A little bit harder to see what's halfway between -3 and +1. But we could do 2 jumps from each one and we land at -1. So the vertex is going to be at -1. Remember, if it's hard to see that, you can always add these two x-intercepts and divide by 2. And we land at -1. So the vertex of this parabola will be here at x equals -1. But we don't know the y value of that point yet. To figure out the y value of the vertex, we'll take that -1 and substitute it into the equation for both x's. We have vertex at -1, +4. We could make a pretty good parabola here, but let's get 2 more points here. Now the parent graph of this equation would be y equals -x squared. And the first move for this parabola was over 1, down 1. So we're thinking our points will be here and here. Let's check it. So let's find the y value when x is 0. So I'll substitute 0 into this equation for both x's. So we get another point at the point 0, 3. We can reflect that over to the other side of the parabola. And we get a nice sketch of our parabola. One more, this has a value of 1/2. So this parabola will be a little bit flatter or wider. First, let's focus on those x-intercepts. So we can use the x plus 6 to figure out that one of the x-intercepts is at -6. And we can use the x plus 2 to figure out that the other x-intercept is at -2. All right, halfway between those two x-intercepts is -4. And if we're not sure, we can always just add those and divide by 2 to find the average of the two x-intercepts. And sure enough, we get -4. So let's figure out the y value of that vertex by substituting -4 into this equation for both x's. One half of 2 is equal to 1. So 1/2 times 2 is 1. And then 1 times -2 is -2. So our vertex has the coordinates -4, -2. Let's get a couple more points by moving over 1 unit. And we'll use x equals -3. So let's find the y value when x equals -3. So I'll substitute -3 into the equation for both x's. Let's see, 1/2 times 3, or 1/2 of 3 is 1.5. Then we have 1.5 times -1. So our vertex will have the coordinates -3, -1.5. Or not the vertex, pardon me, that last point we're calculating. Right, and those points actually do make sense. If we think about the parent graph of y equals 1/2 x squared, the first move on that one was over 1 up 1/2. And the second move was over 2 up 2. So these points match the moves made by the parent graph. So we have a nice wide parabola here. In this video, we learned how to graph quadratic equations in intercept form. This is Mr. Ela, signing off.